All right, so we're given a string S containing just the characters, parentheses, uh, squiggly braces, and square brackets. So they want us to determine if the input string is valid, and it is valid if open brackets are closed by the same type of brackets, open brackets are closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So they're just looking us to return true or false based on whether there's like valid ordered parentheses in this string S. So what do they mean by valid? Like we can look at a couple of examples. Say we have this string. This would be valid, right? Because this open parenthesis gets closed, but not before this bracket gets closed, and not before the squiggly brace gets closed. So this is valid. Also valid would be like this, right? What would be invalid is if we have like, I don't know, like this sort of situation. Like we have this parenthesis, we open a square bracket, but then we close the parentheses before we close the square bracket. So this is illegal, right? That's one example. Another example is where we could just have like an incomplete sort of situation. Like say this is the whole string here, those never got closed. Or say we open with like a closing parenthesis, or a closing square bracket. This would be illegal starting a string like this. So this problem actually gets really easy to do super efficiently. We can do this problem in linear time and linear space. So if we understand what a stack is and how to use it, and then how it kind of applies to well-ordered parentheses in like a mathematical setting, if we understand that relationship pretty well, this problem gets really easy. So, and I'll show what I mean. So we can use this example. And so we know a stack is going to be last in, first out, right? So whatever was inserted the stack last is going to be at the top of the stack, right? So I'll show just an example for a stack. So pretend this is a stack, it's just empty. We'll iterate over this string here. So if we see an opening bracket or a curly brace or parenthesis, we'll put it in the stack. Okay, so that'll be part of our algorithm. So we put it in the stack. We're going to iterate to the next thing. We see an opening square bracket. That's legal, right? So we put it in the stack. We're going to move this way. Squiggly brace, we'll put that in the stack. Okay, and then what we're going to do, as you'll notice, notice the pattern of stuff we have in the stack. Like we have the most recent opening curly brace at the top of the stack. So when we see the closing curly brace, well, what do we think we could check for an algorithm? Well, we could just check the top of the stack, right? Okay, is that matching the same curly brace? Like not looking for like a square bracket or a closed parenthesis, but a closed curly brace has to match that. And we do find one, right? So we would just pop that from the stack. We can say that our string so far is good, right? It's valid. Move to this one. Notice what's at the top of the stack, the square bracket. So we can pop it. We know our string is good so far. Move to this one. Same thing. We know we're good so far. So at the very end of our, looping through the whole string, our stack should be completely empty. And we know we saw a valid, like a well-formed string here of these thingies in the right order. So that's pretty much like the problem in a nutshell. It would be linear time complexity, because we have to look at every character in this string at least once, right? And then the space complexity, because our whole stack can get full, and we might just have an entire string of like opening parentheses or opening brackets or opening curly braces, and then we might never pop anything from the stack. So in the worst case, we have like linear space for like an invalid string. So let's code this. So the first thing that we want is that stack. So in C++, it's just a stack. A stack is literally just called stack. The type will be char, and then we'll just call this char stack. And that'll be empty at first. We also want to be able to look up. So for this problem, when we code it, we're going to run into this pattern where we have to check for matching braces. So I'm just going to put the braces into a map to keep track of them. So I'm just going to use an unordered map, and this will just be constant space. So we're not technically using any extra space that like scales badly. So this is just to help the code look a little bit cleaner. So we're going to have this map. Let's just say, or let's initialize it in place. So let's do that. And then actually, okay, so we're gonna use this to look up, like when we're on the closing braces and we need to look up what we expect to see on the top of the stack. We would expect to see like a closing brace of the respective, or an opening brace, sorry, of the respective type. We would expect to find that opening brace at the top of the stack, right? So let me just to save a little bit of effort here. We need all three types. So let's do that. Or I did this one backwards, actually. Oops. The whether it being opened or closed as the key or value is very important here. So got to make sure that's right. Okay, so that's going to be super helpful for us. And then what else do we need? That should be it for now. So let's loop over the string they give us. So we'll use this kind of style loop. So basically we're just iterating over for every character we're iterating for every character C and S, and I'm gonna use const reference just to because if you don't, this code creates a copy of the string. We don't need the compiler to do that, so we're just gonna say reference, don't make a copy, but we don't accidentally modify this array, so we're gonna say const. That'll save a little bit of space. Okay, besides the point, so the first thing we want to do is I'm going to check, are we seeing an opening brace? So I'll literally just hard code this inline. So do we see this, or let me just copy this whole thing. We see this or this. And this can be any of the types. So like this could be a bracket or a curly brace. Right. So if we see an opening bracket, this is really fine at any point. All we want to do is basically add it to the stack. Right. So we're just going to do char stack dot push C whenever we see an opening one. And that's pretty much it in that case. Now, if we're on a closing brace, we need to basically check. So the stack can never be empty. If the stack is empty and we see a closing brace, then this is invalid, right? So we just need to start thinking about the cases where our string is invalid. So if the stack is empty, let's just return false. Okay, now otherwise we expect to find the corresponding matching opening brace at the top of the stack. So let's just do that check using our map to help us look up. So we'll say char stack. We're going to check if the top of the stack is equal to our map of C at that value, right? So we're basically looking up the closing brace and then checking if it's like the corresponding one. So if it is the corresponding one, we don't have to do anything except for pop whatever's at the top of the stack. Alternatively, if we don't find exactly that corresponding one, it's invalid, right? So it's pretty strict. Otherwise, we're just going to return false right there. Yeah, so that's pretty much it for the loop. And then at the very end, there's a chance that we never closed up these opening braces. So we need to just check one more time if our stack is empty. So, and we can actually just do this in the return statement. So we'll return if char stack is empty, then we will return true. Otherwise, we'll return false. If there's still remaining elements, then it's an invalid order for the braces in that input string. So let's just submit this. And yeah, hopefully this helps. And I'll see you guys in the next piece.